2021 was an important year for Central Coast agriculture. That's the year when the Regional Water Board adopted the latest version of the Irrigated Lands Regulatory Program, also called 4.0. Several new requirements were put in place immediately, expanded domestic well testing being one. Other new components of 4.0 have been slow developing, but will soon impact how farmers grow crops and handle irrigation and stormwater drainage from Central Coast fields. As many already know, the Regional Water Board is a state regulatory agency responsible for enforcing the Ag Order. It is one of 9 regional water boards throughout the state who have adopted similar provisions that affect all irrigated agriculture in the major farming areas of the state. On the Central Coast, Preservation Inc. is a grower-directed nonprofit and is approved as the Ag third-party group by the Water Board. In 4.0, Preservation Inc. has taken over some of the groundwater responsibilities previously handled by the Central Coast Groundwater Coalition. So now Preservation Inc. manages both monitoring for surface water and groundwater. In 2022 and 2023, the organization managed domestic and irrigation well sampling for members and ensured that labs correctly uploaded the results to GeoTracker. While Preservation Inc. works with the Water Board, they are not a regulatory agency and don't enforce the Ag Order. Their role is assisting members to comply with 4.0 requirements for surface water, groundwater, and irrigation and nitrogen management. More importantly, Preservation Inc. keeps growers informed about the Ag Order and where problems are being identified in irrigated agriculture. As for growers, they are responsible for either having an individual permit with the Water Board or joining Preservation Inc. No grower to date has chosen the first option over the long term. Ag Order 4.0 was passed on April 15, 2021. Among other changes, 4.0 replaces the tier system for ranches that was put in place under the previous order called 3.0. Now there are groundwater phase priority areas and surface water priority areas. For the surface water component, work has begun in earnest developing what is being called the Surface Water Follow-Up Strategy. This strategy will outline how growers in priority watersheds address exceedances of pesticides, nutrients, or sediment identified by water sampling. For almost 20 years, Preservation Inc. has been sampling 50-plus waterways on the Central Coast through its cooperative monitoring program.
Priority 1 waterways are those with the most exceedances over the years. Growers farming in those watersheds have 2 ways to comply. As individuals, they can submit a work plan for reported individual monitoring to the Water Board, which was due in March of 2023. Or if they choose the cooperative approach, they can participate in a plan being developed by Preservation Inc. That plan is due to the Water Board on March 1st of 2024. Work plans for medium and low priority watersheds are due in 2026 and 2028, respectively.
This approach is different from the previous surface water program and is intended to address what is now almost 15 years of pesticides, nutrients, and sediment being found in surface waters of the Central Coast. So what are the water quality problems identified through those 15-plus years of water sampling? Most prominent in the early years of the program was a commonly used insecticide called chlorpyrifos or Lorsban, among other commercial names. Due to EPA changes in the chlorpyrifos registration in 2018, its labeled uses were so severely restricted that applications of the product virtually stopped.
Water quality exceedances related to chlorpyrifos have more or less stopped. However, we are continuing to see detection and exceedances of products used to replace this insecticide in quite a few waterways, in particular the pyrethroid and the neonicotinoid insecticides.
And like chlorpyrifos before it, these insecticides are making their way into waterways, primarily through 2 pathways: field irrigation runoff and spray drift moving into waterways. In addition to insecticides, Preservation Inc. monitoring also identified 2 other problem constituents: sediment from eroded soils measured as turbidity, and nutrients or fertilizers measured as nitrate and phosphate. So how are these exceedances going to be addressed in the surface water follow-up strategy?
First, it's identifying which of our members have parcels that drain into the waterway, and then it's performing outreach with those growers about potential practices to minimize runoff and prevent spray drift from moving off-site. In a pilot program that we launched in 2021, Preservation Inc. staff held watershed meetings with growers in 7 of the 16 high-priority watersheds. We developed a step-by-step guide for growers to self-assess the nitrate concentration and turbidity in their runoff. And we also offered toxicity testing to identify pesticides moving off of the fields in runoff. So once growers identify issues in their runoff, they can consider different approaches to mitigating the issue.
Growers are familiar with many of these practices for dealing with these problems, while some are still in the development stage. Because each ranch has different growing conditions and topography, it will be up to growers to decide which practice or practices best fit their unique situations. When thinking about potential solutions, the options depend on whether we are talking about winter storm runoff or water leaving fields after irrigations. For storms like we saw in the winter of 2022 and 23, there's not much to be done but get out of the way. Managing even moderate storm flows is doable but remains challenging. Where more options are being developed involves managing runoff during the irrigation season. More specifically, dealing with the silt, pesticides, and nutrients carried by the irrigation runoff. First, let's talk about managing silt. Michael Kahn has spent years researching a practical way to use PAM, or polyacrylamide, a flocculant, to remove silt from drain water and prevent silt from ever leaving the field. 2 of his newest approaches show promise. The first is an injection system that relies on a series of PAM-filled cartridges installed near the sprinkler system wellhead.
The water comes in on this side here. It goes through these 7 chambers and goes out and exits through these other 7 chambers. Inside the chambers is a cartridge filled with PAM. And we let that water move around the PAM cartridge, and the water picks up a little bit of PAM in it. When we treat the well water this way and it goes into the sprinkler system, when that water hits the ground, it keeps the sediment in place in the field.
Metering the proper amount of PAM into a sprinkler system has always been a challenge because too much can clog the system. Dr. Kahn has developed a design that ensures the PAM is injected at rates that keep soil from eroding, yet don't cause sprinkler head clogging.
Since the water is moving past the cartridges, it just picks up the amount of PAM that can dissolve in, so we can never over-apply PAM in the water.
One of the cartridge systems is installed in a vegetable field that drains into a holding pond, where the water is later used to irrigate other fields. Food safety concerns require that the pond water be chlorinated for bacteria. Less silt means less chlorine is needed when treating the pond water.
The amount of sediment coming off the field is about 90% less than if we didn't use the PAM. And so that could be very beneficial, of course, for water quality. Also, I mentioned for chlorinating that water and reusing it, so you have less sediment in the water. The other benefit is you're keeping the fine clays in place in the field.
Kahn is fine-tuning a second device that meters PAM into field drainage ditches. This applicator is mounted on a platform that straddles the ditch. A flow meter installed in the ditch measures water volume and signals the control valve installed at the base of the PAM hopper. Only the amount of PAM needed for the drain water volume is released.
It can monitor what that flow rate is and actuate the auger to turn for 1 second and drop just enough PAM to flocculate out suspended sediments. Often we have high flows of runoff carrying maybe 2,000 parts per million of suspended sediments. By the time we get down this ditch, it will be down to maybe 30 or 40 parts per million. So we can take out about 98% of the suspended sediments. Also adhering to the sediments is often pesticides, like pyrethroid pesticides. And so those get dropped out. So it benefits water quality by taking out the sediments, taking out pesticides that would be attached to sediments.
Dr. Kahn points out that the silt dropping into the ditch from the PAM is simpler to remove than cleaning out drainage basins. Trickier to remove from the field drain water is the pesticides dissolved in the water or adhering to tiny silt particles. A device showing promise is in its final stages of development by Cures. Cures has been spending the last several years developing a new device called the biochar flume. This device is installed in a field drain and directs the water from the field through a series of containers that contain biochar. Biochar is a temperature-controlled charcoal-type material that is typically made from wood pulp waste. Biochar has a negative charge that clings to positively charged pesticides, so it can be very effective at removing soluble pesticides such as neonicotinoids. This biochar is negatively charged and attracts the molecules of pesticide to the biochar, removing them from the dissolved phase in the water. We've had several years of tests and have promising results. The first couple of years we spent developing the device itself. We have to make sure this device is durable, is able to be installed in a field easily, and has the ability to withstand different types of flows. Focus of the efforts now, after developing the flume and weir itself, which is in pretty good shape, is figuring out how much biochar do we need in each flume, how frequently do we need to change the biochar, and what is the dimensions that are going to be ideal for handling these various flows coming off of fields. These practices and other promising techniques are being tested for applicable use in dealing with water running off of sprinkler irrigated fields. What are management options for managing irrigation events to reduce field runoff? In part, it depends what time in the growing season sprinklers are being used. Sprinklers have many uses: pre-irrigation, germinating newly planted seed, post-transplanting, growing the crop to maturity.
It's essential when managing sprinkler irrigations that the system operator takes advantage of the tools and practices available to minimize field runoff from sprinklers. One important reason to do this is to minimize the potential for pesticides, nutrients, fertilizer, and silt that may run off from cropland on the Central Coast.
During the growing season, when rainfall is not a factor, there are practices that can help minimize or even eliminate field runoff from irrigations.
Combining proper pesticide application management with good irrigation practices for an agricultural site can significantly help protect water quality. Michael Kahn has spent decades studying ways to help growers manage and minimize runoff from fields.
Growers are very interested in trying to reduce the amount of runoff they have in their fields. It's both a food safety issue as well as a water quality problem. And in many locations, we don't have a lot of water available, so they want to use that water as efficiently as possible.
Dr. Kahn describes two main approaches for mitigating the impacts of farm inputs on waterways: minimize irrigation runoff and retain, treat, or dispose of runoff. One of the fundamentals to minimize runoff is designing an efficient system that allows for even water coverage of a field.
When a system is designed and laid out for optimum uniform distribution, water is applied evenly across a field. That means you're not overwatering one side of a field and leaving the other side dry. An overwatered section of a field can be a source of water runoff. Tracking how much water is applied and soil moisture content are also good practices to ensure that water is applied evenly across the entire field and soil isn't getting too saturated.
When we're operating sprinklers, they will start producing more runoff when the soil becomes saturated. So a good indication when you need to turn those sprinklers off is when you see a significant increase in the volume of runoff.
This shows a field close to runoff. This field has been irrigated enough to match crop water need at emergence growth stage. This lettuce is just emerging. It's been watered for about an hour. This field has been watered for an extra 2 hours, and the soil is clearly oversaturated with visible runoff. One technology seen more often in Central Coast vegetables is drip irrigation. When systems are well maintained, drip irrigation proves to be an effective tool for both optimizing yields and virtually eliminating field runoff. While drip is most widely used for in-season irrigation after starting the crop with sprinklers, some growers are having success using drip for crop germination.
Instead of using sprinklers for establishing crops, we can bury the drip before planting and germinate up the crop with the drip tape. And this minimizes any runoff you would get from sprinklers during establishment.
Under certain weather conditions and soil types, drip holds the most promise.
This method of drip germinating crops is ideal for soil types that would be sort of a silt loam to sandy loam texture. They're ideal in areas where you would have very windy conditions and you wouldn't get good uniformity with sprinklers. They are ideal in soil types that are prone to crusting because you have to irrigate very frequently just to keep that crust wet.
Many in agriculture are looking to larger scale solutions that direct field runoff through a constructed wetland. These wetlands are built to collect water at the bottom of a watershed or field drainage system and circulate it through a series of ponds and channels lined with dense vegetation. Such a system has operated for more than 5 years at the base of Morro Coho Slough.
This wetland system relies on 2 phases to treat the water. Water first flows through a pretreatment sediment basin and wood chip bioreactor, where sediment and some of the nutrients are removed. The water then flows through a circuitous 18-inch deep channel built across a 12-acre parcel of unproductive farmland. The channel banks and floor of the wetland are planted with vegetation that effectively settles out sediment and filters pesticides carried in the drain water. Bacteria living in a low oxygen environment at the sediment's edge use nitrogen from fertilizer for respiration, emitting nitrogen gas to the atmosphere. Numerous samples taken downstream of the wetland treatment system or bioreactor wetland combination show that the system significantly reduces nutrients, suspended particles and silt, pesticide concentrations, and toxicity. We at the Central Coast Wetlands Group are leading the projects on the Morro Coho Slough watershed. Our tests are showing that on average, nitrate levels are reduced by 99%, phosphate by 73%, and turbidity by 90%. We've shown that the Castroville Slough treatment wetland can remove nitrogen from the drain water draining off of 1,000 acres of irrigated land. Our data show that the system has reduced nitrogen in the watershed drain water by approximately 11,000 kilograms per year. This has helped the Morro Coho watershed reach water quality objectives set by the Regional Water Quality Control Board. Actually, between 2016 and 2019, after this and other treatment systems were installed, there were no nitrate exceedances in the Morro Coho watershed, which was not the case in previous years.
The Central Coast Wetlands Group is working with Preservation Inc. and the Regional Water Board to credit growers in this watershed for meeting nutrient water quality objectives. Another area of focus for keeping pesticides out of drain water is managing drift during applications near waterways. While spray drift may seem like an unlikely contributor, water samples are analyzed down to parts per trillion, and commonly used insecticides, such as neonicotinoids and pyrethroids, are easily detected in water. So even a field with no irrigation drainage could contribute to downstream exceedances of pesticides when drift moves from a treated block into an adjacent drain ditch. Your number one objective is never allow pesticides you are applying to enter any waterways, no matter how small the waterway. By waterways, we don't just mean an area where water is flowing. We also mean areas where water could be flowing and will be flowing. For example, drainage ditches and drives next to the crop. All areas that can get wet from rain or runoff created by irrigation water from sprinklers. There are only a few ways pesticides can reach waterways: spray drift, irrigation water running off a field after an application, stormwater running off a treated field carrying soil into a stream or creek, mixing and loading at a site where water and soil could move to a nearby waterway.
Here are some practices that can protect the environment. Be aware of your surroundings. Know the area where you will be applying pesticides. Use a map to identify all the possible pathways to field drains and waterways. Suggest to your supervisor additional ways to help keep pesticides on the treated field and stop off-site movement. Make sure your equipment operation and work procedures are precise and controls are fully functional. Be sure you have the proper tools to make equipment adjustments.
One important step that involves the equipment owner is installing a flow monitor device. This allows the equipment operator to have a visual check to ensure material is flowing correctly and a proper application is being made. Another tool for the equipment owner to consider is installing the diaphragm check valves to the hose just before the nozzle, especially if the drop nozzles are being used. A check valve prevents any liquid from dribbling out of the nozzle after the spray boom is shut off.
Now, here are some practices once you are on the tractor. Spray rows of crops adjacent to a waterway only when the wind is blowing away from the waterway. Only turn on the nozzles after you have entered the field. Don't turn the nozzles on before they are over the crop. You don't want to spray pesticides on the drives surrounding the field. Likewise, turn off the nozzles at the edge of the field. Keep the application on the crop and off everything else.
Why is it a problem for a small amount of nozzle drivel to fall on the road when making a turn? Should the road get wet from sprinkler overspray and water leaves the field, it could pick up some of the material left on the roadway and carry it into a waterway. That may seem like a really small amount dribbling out of a nozzle, but remember, the Regional Water Board is looking for pesticides in field drains at parts per trillion.
Other things to consider. Be aware that too high of nozzle pressure can lead to off-site movement and drift. Driving too fast when spraying can cause excessive drift. Turn off nozzles when the spray boom is over a drain ditch.
Another important consideration for field edge roadways is when insecticides are applied by shanking in prior to planting. These soil treatments are an effective way to control insects and involve placing pesticides in the row using small shanks or knives. These shanks with open-ended lines can dribble small amounts of liquid after being turned off and the rig raised on row turns, a problem that can be solved by installing check valves. These check valves stop the nozzle dribble on row turns.
Operators occasionally like to stop the tractor on the turn road, turn on the shanks with the toolbar out of the ground, and check to make sure none of the nozzles are plugged. Not a good practice. Do that at least 25 yards into the field. Better yet, in the middle of the field, but never on the turn road. That way, the liquid lands in the field where it belongs. Never flush the boom on the drive at the edge of a field or on the mixing and loading site.
One new sprayer is addressing drift problems not only with shielded booms, but by treating only the crop and not the soil between the plants. The equipment is called the Mantis Smart Sprayer. This applicator uses camera-controlled valves to turn nozzles on and off, only spraying when above an individual plant. The sprayers, in commercial use for more than 2 years on the Central Coast, dramatically reduce the overall amount of insecticide applied to a field.
The onboard camera system on the Mantis Smart Sprayer measures pixel size of each plant and adjusts the rate accordingly. We regularly reduce insecticide application volumes by 85 to 90% at the label rate and still have effective control.
Water regulators are taking a hard look at the water running off irrigated cropland. They can measure farm inputs at parts per trillion in the drain water and will take actions against growers and operators if impacts to water quality are not addressed soon. It's no longer a question of if water regulations will become stricter, but rather when. The question for growers, applicators, and irrigators: what is the best solution to fit each unique field situation?
A Cures video production. Sponsored by the California Department of Food and Agriculture and the Office of Pesticide Consultation and Analysis. With cooperation from the University of California Cooperative Extension.